All right, good day, everyone. Today we're going to be talking about synthetic division. And synthetic division really is just a fancy way of saying dividing out polynomials, okay? All week we've been kind of working on operations, right? We did adding, subtracting, we did multiplication yesterday, and now we're going to be doing division. And the funny thing about division is that we really have to find specific methods to actually divide out polynomials, okay? So what we did is we created a way to actually divide them out, calling it synthetic division. Now, the actual process is going to seem complicated just because there is a lot to do to actually set this up. What I can tell you is that once you have the setup down, synthetic division is actually fairly easy, as it just kind of is this constant pattern that you use. Okay? So one of the things that we are going to focus on is really focusing on how to set this up, how to work it out that way. And then from there, what we can do is start building up with the actual math itself, okay? Because that's the number one thing I want a lot of students to understand is that the math itself isn't really that bad. It's just getting to that point where setting it up and getting everything in the right spot so that you can do the math, okay? So here's how this is going to work. Let's say I want to divide letter A here. We have 2x squared plus 7x plus 9 divided by x plus 2. Well, how this works is to start my setup, I'm going to start with a little, let's call it like a half a box, a backwards L, however you want to say it, with a line underneath it, like so. Okay? The reason I do this, the reason I actually take the time to do that step is because it kind of lines up everything I need to plug in. So first off, we need to plug a number into this little backwards L. Well, how this works is we always look at the value that's being divided, which is an x plus 2 right now. And what we do is we take that number that they give us. In this case, we have plus 2, and we're going to flip that sign. So we're going to have a negative 2 inside the box. Okay? After that, all the other values just come right from the equation. We have a 2, a 7, and a 9. And at this point, technically synthetic division is set up. Now, like I said, I don't really think the setup's complex. It's just different. Okay, it's something you have to get used to kind of using. At this point, we are officially ready to start our math. And the one thing I can tell you is that when I do the math, it's kind of just this reoccurring pattern until I get to the end. So how this works is what I'm going to do is always bring down the first term. Okay? So I bring down the positive 2. Then what this becomes is this pattern of multiply, and then we add together. So we're going to take the box number and the 2 and multiply them together. Negative 2 times 2 is negative 4. And as you can see, I write that over in the next spot over. At this point, this becomes an addition problem. Or in other words, 7 plus negative 4, which comes out to be positive 3. And now I repeat the process. I do negative 2 times 3, which is negative 6, and place that in the next box over. And then I rinse and repeat until I get to the end. In this case, I add that over. This becomes 3. At this particular point in time, I'm at the end of the problem. So what we have here is a particular answer with a remainder. This last number over here is always going to be your remaining value. Okay, so in this case, we have a remainder of 3. While the other two numbers are actually an equation. And how we write this equation is we focus on the original value we have, which is a squared, and we take 1 away from it. So if I have a 2x squared, my answer should only be a single x because it's 1 less. So I'm just going to take the two numbers provided here and basically count down. We have 2x to the first plus 3. And that is my final answer. 2x plus 3 with a remainder of 3. Okay? Now, like I said, it's kind of this weird pattern of constant reoccurring math where you bring down the first term, you multiply, add, multiply, add, multiply, add. And once you get down to the final problem, or once you get down to the final number, that value just becomes a remainder, while the other values actually become the new equation. Okay? So before I end this video, let's talk about one slightly different circumstance. In number 3, we have to talk about certain cases where what happens if you're missing a value, okay? So first and foremost, let's get our setup going. We do our half box, our line, and in this case, I'll even throw in an addition sign in between, okay? We know up in the box, we're gonna have a positive 3 because it's opposite of the value given there. And then across the line, I have to draw my numbers. But here's the one thing you have to understand. I am not allowed to skip a value or an exponent. I always want order. So while I have a 4, a 3, technically I'm missing an x squared. Okay, it's not there. So what we do is we always account for it by plugging in a 0 for that value. So if I go down the list here, I have a 1x to the 4th. So I'm going to write a 1 to start. I have a negative 2x cubed. So I have a negative 2. Because I don't have an x squared, I'm going to fill in a 0 to replace it. Then it is 3x plus 1. So that's the first key thing I want you to understand. I had to plug this 0 in because there is no x squared. Okay, we have to account for missing exponents. We always want order, and if they don't give it to us, then we have to somehow make it. And we do this by plugging in our own zeros. At this point, we're going to go ahead and follow the math. Positive 3 times 1 would be positive 3. Add those together, we get positive 1. We continue this process. 3 times 1 would be 3. 3 times 0, or excuse me, 3 plus 0 would give me 3 again. 3 times 3 is 9. Add those together. That gives us 12. 3 times 12 is 36. Add those together. We get 37. Notice once again, just for anybody that is confused, all I'm doing is taking this number, multiplying it to this whole bottom line down here. And then when I bring it up into this middle line here, all I'm doing is adding those numbers together. So you multiply on bottom, and then you add in between. And it's just that constant pattern of multiply, add, multiply, add, multiply, add, okay? At this point, we can get to our final answer. We know 37 is our remainder. And what we're going to do is we're going to count 1 away from the original. If we had an original equation of x to the 4th, this would be 1x cubed plus 1x squared plus 3x plus 12 with a remainder of 37. Okay? We'll go over this in class a little bit more. If you have any questions, bring them there, and I will see you soon. Have a great day.